Welcome to today's presentation, Best SRE Practices to Help Developers Troubleshoot Kubernetes. My name is Genevieve Cross, and I am the Director of Demand Generation here at StackState, and I'm happy to say that I am your host for today. And I have the pleasure of introducing our speaker, Andreas Prince, who is our Chief Product Officer. But before we pass it over to Andreas, I just want to go over a little bit of housekeeping. So first and foremost, I wanted to let everyone know that this presentation is going to be recorded, and a copy of the recording will be sent out to you and everybody who has registered. We also have a Q&A going on. So as you are going through the presentation, if you have any questions at all, please go ahead and enter your questions into the chat box, which is on the lower right-hand corner of your screen. And without further ado, let me pass it over to Andreas. Andreas?
Yeah, thank you so much, Genevieve. And nice meeting all of you here online, virtually. There are actually still a couple people coming in the room here, so we also have some visitors, if you see some mirroring behind me. And actually, it's really cool to have this webinar. It's actually the first webinar that I'm doing this year, which is probably obvious. And there's still quite a bit of people coming in, so let's take some time to do a brief personal introduction before we really get to the content of the webinar. And as Genevieve already mentioned, my name is Andreas. I'm with the company for quite a while, and I'm leading the product team, doing trying to guide all the product developments, the user research, and all these type of activities. And if you ask me, who am I? Well, first and foremost, a colleague, but also a father of 4 children and my wife. What I truly like is flying drone. So as a hobby, really trying to take a bigger view, raise up a little bit and see what the perspective is of the world. And I do think that's kind of similar to troubleshooting Kubernetes. You sometimes need a bigger picture to really understand what's going on. And yes, detail matter, but if you're finding something, zooming out a little bit is powerful. The other probably more recent hobby is ChatGPT, and you see one of the results over here on my screen, a little poem that I created last week, and there's one ready for tomorrow. So if you would like to see a couple more Kubernetes troubleshooting poems, you should certainly follow me on LinkedIn. All jokes aside, I really think that that ChatGPT is a powerful instrument, but still, it's guessing and it's building its knowledge on what already happened in the past. And if you're troubleshooting Kubernetes, you need a more accurate view. And that's also a topic that we would talk about in this webinar. All right, what is it that we're going to discuss? There are a couple really important topics that I would like to elaborate on. And the majority of it is based on the research that the product team at StackState has executed in, I would say, the last 5, 6, probably 8 weeks. Really diving deeper into what are the struggles that larger and smaller enterprises struggle with if it comes to troubleshooting issues on Kubernetes, or to be more specific, what are the issues if you deploy applications to Kubernetes that your software developers are struggling with? And believe it or not, there are quite a lot of them. And in today's webinar, we take a more positive note. We take these learnings and we share insights on how many of these companies actually did it in the right way, that they focused on knowledge sharing, and that the practice of site reliability engineering, or if you like, platform teams, are working throughout the entire organization to make applications reliable and robust. So let me take you through the current approach of troubleshooting. What do we see at many companies, and why do all of these approaches only provide a piece of the puzzle? How can SRE teams drive knowledge sharing? Super important to think that through, and whether or not you call that an SRE team or another central team that has the knowledge, that's really important. A couple ways to do so, just super practical, and then also a little glimpse into how tools can help you to build that total understanding and really focus on sharing that across your organization. And that's where we take a closer look at StackState as well. So if you're not so familiar yet with StackState, please stay a little longer with us, really to the end, to show you what StackState can do to help you troubleshoot Kubernetes. And speaking about the current approach, I thought let's introduce 4 characters to explain a little better on how current teams, SRE teams or engineering teams, are trying to troubleshoot their applications running on Kubernetes. And these are the 4 that I would like to introduce, and they reflect various tools and type of data that the teams are using. The metric and trend spotter, the log aggregator, the event watcher, and last but not least, the tracer. Do you go with me to take a closer look on what they do? The first one, the metric and trend spotter, is probably the one that you're most familiar with. And with literally all of the companies we started looking into, we started talking to, that we involved in our research, the majority of them started with the Grafana dashboard for a good reason on top of Prometheus, because both are relatively easy to set up and already pretty rapidly provide you a deep understanding to see what's going on with your application. The majority of the insights you get are looking from the outside to your components and really see the trends over time of what's going on. The downside, what we've discovered, is that if you want to go from one area of your cluster into the other, if you want to go deeper from your services into your pods, if you want to understand the bigger picture, you still need to know how that bigger picture looks like and go from one dashboard to the other. The other feedback that we got is that many engineering teams who are new to deploying applications to the cloud, they struggle with how to set up the best dashboard, or what are the charts, what are the thresholds I need to set, the alerts that will help me understand what's going on. And that's exactly where your SRE team can help to set up the right stuff and then distribute that across your organization and your team. But primarily seeing the trends from a performance perspective, a reliability perspective, a utilization of your resources, that's what these metric and trend spotters will see. But let's take a look at the second character. The second one is the event watcher. Sorry, the second one is the log aggregator. And that's most of the time the second one also in the implementation journey of truly doing observability that people look into. And why? Well, your logs tell you something about more detail, tell you a better detail and a bigger detail on a particular component. They help you to understand where particular components start to fail, what are the errors that are served to you as a user. The challenge, again, is that you get the logs from a small amount of resources or a single resource. So you need other tools to start streaming them into a central platform. Over here we see an example of Loki, which will help you to analyze logs and again to put measures on top of it to be warned early on. A powerful way to take a close and a deep look into the errors and the stuff that's actually going on. But most of these events disappear after a little while. So how do you go back in time and really understand what happened in the past? That is an important missed opportunity if you only use logs. Teams often start using various dashboards, and then when they really need to troubleshoot, they start using these log aggregators. But there's more. The other one are the events. Here's an example of Instana showing a lot of the Kubernetes events that are going on, and they will tell you something of the behavior of the components. Pods being killed, new containers being pulled and started. It gives you a good understanding of the actual behavior of an individual component or a set of components. But again, they often don't provide you the cause of the issue that you need to know. Together with the other two, the perspective gets richer. But what we notice here already is you have various tools to really get to the answer. And the fourth one is probably the most important one from an end customer perspective. An end customer, you might think, yeah, because that's where the site reliability engineer will be focused on. What is the reliability of your systems? But also, what is the performance of your systems? And how can you optimize the performance so the customer, the end customer, will experience a better flow? Over here, we see an example of Kiali that shows us the trace information, all the components that are linked together and ultimately form an end-to-end trace with a particular duration. And the longer it takes, we know, the worse the more horrible the customer experience is. And it is important to dive deep into trace information to optimize, to really understand how they're connected and to start optimizing the individual traces. And these four combined start to give you the total picture. But what we've seen, and that's probably more important, is how, as a site reliability engineer, do you understand what your teams need, what the company needs? Where's the biggest need? Is that in performance? Is that in reliability? And last but not least, what is it that the end customer needs? Is it indeed the optimization? And these are just some of the struggles that many of the teams we've spoken to are struggling with. They use various tools. So whenever they go from one tool to the other, they need to dig their way into the dashboards or into the logs or into the trace information. And they continuously switch between all of them. The other challenge that you will notice in your and that you will face in your company is that your regular engineering teams who need to focus on software development, they're often spending a lot of time learning Kubernetes, learning how to troubleshoot, knowing and understanding the basic practices and principles there. So if you think about spreading knowledge across, immediately you need to think about, hey, what is the knowledge they need? Or are there tools or solutions in the market that can actually take away that burden of building a deep understanding? Dashboards then are not always useful. The dashboard I was just showing, for example, in Grafana, because they provide a piece of the puzzle. How do you give them the bigger piece? And then last but not least, the complexity of the cluster might be the issue as well. How is everything wired together? And I've heard a couple examples where troubleshooting a single service or a single namespace where a team was responsible for wasn't the issue, but the single team was responsible for multiple applications and also pieces of the cluster they actually haven't built or deployed towards, and then they struggled with that. So what it brings is a lack of a holistic tracking and therefore hard to determine what is the cause of the issue, and at the other hand, not possible to remediate quickly. And funny enough, these are the two basic or fundamental drivers behind site reliability engineering. Remediating issues quickly, reducing toil, and at the same time, be powerful in understanding and spreading the knowledge across the organization. And before we go deeper into how to avoid, what to change, let's do a little poll. So Genevieve, if you could bring up the poll, that would be really nice. All right, the question is, what are your Kubernetes troubleshooting issues? And feel free to check one or all of them if you face multiple of these issues. Because we also learned that it isn't similar for every organization. Companies who are more or further down in the journey of moving to cloud native application landscapes, they already have more practices in place versus the ones that are just starting. The smaller teams with less dependencies can probably, or what we've seen, go faster than the bigger teams who have more dependencies to manage. The tools who started earlier on the full automation journey with CI/CD practices, they're also a little quicker in adopting these observability practices. So depending on where you're coming from, your tech stack, you might have different challenges. All right, let's see the results. There we go. So absolutely the two front runners, a lot of context switching between tools to find the answer. And the second one, a lack of strong Kubernetes troubleshooting knowledge. Well, that isn't a surprise. It's confirming what we thought. The funny part, just to keep the poll results up here, is the complexity of Kubernetes and the high frequency of change. And that is for a reason, because if you recall the previous title of the slide, Kubernetes is taking away a lot of the burden that engineering teams in the past had with the more traditional infrastructure. It's the entire promise that you don't focus necessarily on the Kubernetes layer. The challenge is when you start deploying applications and the interaction between your application microservices and the Kubernetes layer, that's exactly where the trouble is. So thanks for answering all of this. It would be really good later in time if we take a closer look at the elements of knowledge sharing, that you keep this in mind to really focus where you should start with your knowledge sharing activities. All right. Then one step deeper into site reliability engineering. And if you were expecting a more technical, in-depth training on site reliability engineering, there's a ton of stuff out there. So I would certainly recommend to look into that. Today, we would really focus on the bigger picture. And if you think about sharing knowledge in an organization, that's not often about a single tool or a single person teaching another one something. No, it's often about the culture. How open are you from team to team? And are there established practices, moments during the day or the week or the month where knowledge sharing is applicable? And we'll take a look into that in a bit. But first, the site reliability engineer. The first and probably foremost important thing is the goal. What is it actually that your site reliability engineering team is doing? Where is it focused on? And at the highest level, it should all be about the customer experience. Yes, we go deeper in a bit, but what are the goals that your team has set, your site reliability engineering team or your platform team? What is the goal that they've set with regards to stable systems, availability, and reliability? And I'm calling this out in particular because what we've seen is that a lot of teams just start with implementing practices without first realizing what is it that matters the most at this moment in the journey of my company. Developer speed is also often one of the important aspects. And what we see in a difference in goals is that the site reliability engineer is really customer focused, the reliability of the systems. The platform team, which is more often focused on the platform, providing a Kubernetes environment to the software development teams, they're often focused on standardization and developer speed. And that is important to know because mixing them together could work, but if they serve two different goals, they can start to clash, and then you need to identify what matters the most. So the goal is the first step. Then the second important thing is they're there to support the other teams. Often, and most of the time, what we've seen is that not every team has a site reliability engineer. So the main question is, how does your SRE team or your platform team enable the others to become more effective? And that's for a reason. Because not so long ago, software developers were just focused on development and a little bit of continuous integration. And from that moment onwards, let's say 5-7 years ago, a lot of work started to come to these development teams. Deployment to production, a little bit of monitoring, security testing, test automation, compliancy. And you can imagine that all these waves are a wave of knowledge, of new tools, of new practices. And yes, you can automate a lot of them, but still quite a lot. And it is important to understand and to position your site reliability engineering team or your platform team, not only as a team that fulfills tools, but that also has a strong focus on what is it that I need to share and where do I need to support. And if I would ask to raise your hand, you would probably indeed raise your hand if it comes down to my engineering teams are overwhelmed with what needs to happen. And not only about what needs to happen from a feature development perspective, but also what needs to happen from all these automation practices that are coming towards them. And then if you think about it, then just overwhelming them with another wave of dashboards, log aggregators, trace information, that's quite a bit. So you need to realize, how can my SRE practice help you with that? And then if you think about the automation, there are actually two ways they could serve the teams. One is, what are the tools that your company has in place that help these engineering teams to troubleshoot when things go wrong? An SRE team, sometimes a platform team, can help you to set up these tools and to establish well-defined practices, for example, on doing postmortems, to really focus on remediating the issue on one hand in the first place, and at the same time to take the learnings and avoid that from happening next time. So a part of the activities that you need to train your teams in is really focused on the remediation. Because if your end customers are impacted by a system that gets slower or is even entirely down, or particular services can't be reached, that has definitely an impact on the customer experience and how they would perceive and value your services. And this is, I can imagine, and also what we've seen in the research, where most of the companies are focused on. And that's okay. And that's probably the most important part to start. But the other element should not be underestimated. That is all about the optimization, removing the waste in the process and really focus on fast delivery of new capabilities. So if you're more in calm waters and there are not too many disruptions that needed to be remediated, then you need to ask yourself the question, okay, where in the process can I start with automation? Where in the code base can I start optimizing to get a faster experience? Where can I shorten, for example, particular durations of a trace to ultimately give the end customer a better experience? And that is an equally important part to focus on. And that's also where a lot of engineering teams who are primarily focused on the development of new features not necessarily have the knowledge where you as a site reliability engineer can help them out and push that out to the development teams. Because it's ultimately not that single team that does the delivery. It's ultimately all the software engineers, the software developers that push the applications out into production. And the more new features, reliable new features, you can push, the better you can distinguish yourself from competition in an era where everything is about digital. And then if you go back into the 4 characters that we introduced, the tracer, the metric, and trend spotter, reducing the amount that people need to switch from one tool to the other is also important, because if you get there, the engineers can more and more focus on the core activity, which is software development. So what we've seen, the goal is to focus on customer experience and developer speed. We've seen that many engineers or engineering teams struggle with the amount of capabilities that come towards them. And then, really important, how can your site reliability engineer help you to get into a stable state, troubleshoot issues quickly, as well as focus on the optimization of the process, so you can get your hands free to deliver capabilities. And with having said that, let's take a closer look at what are just some practical instruments that you could start straight away tomorrow. Not looking into tools yet, but just a little practical examples that we've seen working at our customers, but that we're also practicing ourselves. But before I get into that, you might wonder, what are models to set up a site reliability engineer in my company? How do I actually start with the practice? And what we see is actually 3 different models. The first one is a central SRE team, and this is the most common one. There's a team that sets up the practices, that sets up the tools, that also most of the time defines the policies that are applicable into your entire company. And that is super powerful, because in minutes, in days, in weeks, there can be a established practice that can be rolled out to the various development teams. It also has a downside, as you can imagine, because teams with a little resistance, or teams with a different tech stack, or teams that are simply not that far in their journey of automation, they're poorly served with an approach like that. And if that's the case, I would recommend to take a look at the middle model, the coach model, a coach squad, where you, as probably an engineering leader in your company, identifies the weak spots in your landscape. And I'll tell you, that often starts with the customer-facing applications, because that's where the experience is impacted the most. And a coach squad has a couple SREs in it, and they will accompany 1 or 2 or 3 software development teams for a couple weeks, a couple months, to build up the practice and the knowledge, so whenever they leave, the team can take over themselves. And that is actually a good way, because there's a lot of times also some engineering, some coding involved to optimize particular applications. And if you've never been focused on that, getting guidance there is super useful. And the third model is probably the best model you can ever imagine. But we all know that that is also a model that is probably the hardest to achieve. It's simply having SRE knowledge, site reliability engineering knowledge in all of your teams or in most of your teams. That will be the ideal state, where there's someone continuously looking at these practices, implementing new tools, optimizing processes, and removing waste. That should probably be your goal, but we all know that that is probably not realistic, simply because it's yet another practice that is pushed towards the development teams. However, for your most critical applications, you certainly should think this through. What is the level of knowledge we need at the minimum? And then probably you can complement that with your central or with your coach squad. But what is the minimum type of knowledge you need to have in your team to build that stable and robust landscape? So think this through, and probably if you already have a SRE team, assess with the team where is the biggest need, where is the knowledge needed the most, and then start focusing on these type of areas. And also be brave enough, if teams are stable, let's move on and let's start to focus on the next weakest area in your landscape. And how could you do so? Well, first and foremost, and that's probably my most favorite instrument, is building a culture of doing blameless postmortems. The entire practice of site reliability engineering obviously is focused to remediate as fast as possible, restart, add more memory or whatever to get the customer going, to keep the application in a stable and reliable state. However, an important activity not to ignore is to really understand what happened. What was the series of events that ultimately caused the issue that you just remediated? And doing postmortems, an extensive debate, discussion with your senior engineers from the platform team, the software developers, the SREs, is super helpful to really understand what happened. And sometimes you need to be a little bit of a detective to go back and really understand. And hence the characters that we just introduced. They can really look into the data, crunch it, and understand the pattern. And that culture of blameless postmortem is important. It happened. That's a fact. Now the question is, what is it that your organization would like to learn? In our company, that write-up that they produce, a small write-up, is always shared with the entire developer community internally. Why? Well, because we would like to avoid that issue from happening again. And second, we always use a blameless postmortem to identify more policies or monitors, how we call them, to observe the application even closer, ultimately to prevent this issue from happening again. The other really important activity to focus on is how can you better understand what's actually happening in production? And you can argue, yeah, obvious, monitoring. But if you're here a software developer, how much do you know of the behavior in production? What if the traffic or the amount of users would double? How does your system then behave? What about the trace information? Is there, for example, performance degradation going on, where time after time you deploy a new version of a particular service and ultimately it starts slowing down? Building a good understanding of what's happening in production is really important. And that's a way, what we believe, of knowledge sharing as well, going over it, assessing it on a Friday afternoon. Knowing it and understanding what the behavior is important to ultimately spark the engine of optimization. The other one, and we've touched upon that as one of the activities of such an SRE team, is building a repeatable process. And that's probably not necessarily the production part, but that's all the steps that will lead into production. Because still 70% of the issues you face in production are caused by a change that's pushed out. Standardizing and automating that, making it super repeatable, will absolutely help you to build that reliable process. And another important part is if new engineers start to onboard, often the question is, okay, tell me the functionality, tell me the purpose of this application, but also tell me how to get software out in production. The further this is documented as an automated pipeline, the easier it is to understand what's actually going on. And if you're new to this topic, I would really recommend you to look into the DevOps research, the DORA assessment, to understand what's going on that side of the automation. And then I truly believe if you as a company has decided to move to a cloud native landscape, you need to think through how to make everyone an expert. And I'm not saying that everyone needs to know as much as your SRE team. The challenge is how can you utilize the knowledge, or how can you spread the knowledge that a site reliability engineer has so other teams can benefit from it. And today there are really good movements going on there in the field. And one of them, or a couple of them, I would like to call out. The first one is OPA, Open Policy Agent, where the experts articulate policies on how to use infrastructure, how to use or how to set up a compliance landscape. And once articulated, they will be applied to everything that's pushed into production. StackState there takes a similar approach. It enables the site reliability engineer to define monitors, which are the policies, for example, about replica sets, about secrets, about where containers are coming from, about thresholds set on a particular resource. And then whenever your software development teams start deploying them, they will get a warning if they're not in line with the policy. And that will do two things. First and foremost, increase reliability. But secondly, they will see immediately what's happening. And that sparks a learning cycle in their mind. So whenever they deploy next time, they take that into account and actually deliver a better version of the application. So that's another way of thinking that through. Automating or capturing the knowledge into policies, into monitors, and then distribute that or apply that to everything that's pushed into production. The fifth one, and then there's a final one, a sixth one, is all about the fun part. And just think about, what are your tech days? Do you have an innovation day? Do you organize hackathons or other ways to share knowledge? Are there pizza sessions during lunch, depending on where you are on the earth? But these are valuable instruments to have the conversation. What I've seen working nicely as well, if big outages are impacting you, or just a black swan, a big outage never happens, take that into a tech day or take that into a learning session and really share that, discuss that through, and take that learning to move forward. Often, if it's about reliability, again, an SRE can absolutely take a leading role in combination with a software developer. And then last but not least, knowing your history. Well, is there a statement somewhere about the history? But knowing the history is important to take the lessons and apply them for the future. If we take a look at observing Kubernetes, often the data is gone in a day, a little longer or even shorter. So how do you know the long-term patterns? If you would use Prometheus, often the data is just stored for 2 weeks. And yes, in 2 weeks, you can spot some performance degradation. But for some others, you need longer time data storage to really understand what's going on. So if you're looking for a troubleshooting solution, take this into account. How much of the history, of the events, of the logs, of the metrics do you need to know what's going on? And StackState, in this case, takes a much longer look. So it stores the data, the metrics, the events, the logs, the trace information for you for a month or even longer to really understand what's going on and detect particular patterns and take action on it. So we've seen that sharing knowledge can be really simple with practical instruments. It can be verbally through a blameless post-mortem, but it can also be automated through your CI/CD practices, your observability tools. And it also has something like, what is it that I actually would like to achieve with my organization and with my company? And that's where we believe at StackState that a tool should actually be supportive to helping you out. And StackState takes 4, approaches to that to make that happen. So how can a tool further increase the effectiveness of your team? And the first one I alluded to extensively, because I'm a firm believer that you need to see if you can find a way to codify, to encode the knowledge, turn them into practices, policies that your monitoring tools will automatically apply. And then, as said, whenever an issue occurs, it will be flagged and your engineering team can act upon. That drives really a learning cycle. So if you just stick to dashboards, it's much harder to apply these policies. If you only take a look at trace information, it's much harder to start applying these policies. And that has everything to do with the second one. You need that holistic picture almost in a single screen to really understand what is happening. You need to find a way to see, hey, I see particular trace information, or how are the metrics from my pod related to the metrics from my service. And by getting the data into a single place, it enables you to do probably an even more important activity, and that is connecting the dots. Visualize all your dependencies, and obviously Kubernetes starts to provide us with service maps. If you use traces, the trace information would start to help you out defining an end-to-end trace. But there's much more, because also your metrics and your events will tell you something about an issue that need to be resolved. So connecting the dots, and that's what StackState does, is really important. I'll show that in a little bit. And then last but not least, we talked about making best use of your smart software developers. If they are not so aware in troubleshooting issues on Kubernetes, the question is, what are the tools and the practices you use to guide these people in fast remediation? How do you point them to particular data to make a judgment on how to solve it? Or even more important, how can you give them already the recommendation on how to solve the issue entirely, or to execute the command that would solve it? Because remediating is of the biggest importance there. So it's about expert practices, it's about data, it's about connecting data, and last but not least, it's about smart detection of what's really happening and then guiding the people through that. All right, let's summarize before we look into how StackState does this. What we've seen is that there are four approaches, roughly four approaches, and often a little bit combined, that would help you out with troubleshooting Kubernetes. They're not always providing you with the full picture, as we've seen. Sharing knowledge is really important, because a lack of knowledge is simply holding you back to remediate quickly, but also to optimize the process. Positioning your SRE team in the right way will absolutely help you to share the knowledge in your organization. And last but not least, I would really like to challenge you to think through the tools that you're using. And that's obviously where StackState can help you out. So we try to take an innovative approach to troubleshooting Kubernetes by applying the exact four principles that I have just alluded to. And if you don't know who StackState is, well, you certainly should check it out. A couple G2 reviews if you like, to really understand what we do and how customers appreciate. But as you can see here on the logos, we're really serving big customers in telco, insurance, in banking, but also the smaller ones that are doing business to business or even business to consumer services. Why? Because it doesn't matter much the size of the company. What really matters is, are you focused on remediating your issues as fast as possible, and do you need help to get there? So what makes StackState unique from the examples we've just seen? The first one is, there are these out-of-the-box practices included. The policies that you need to apply are included in the solution. So whenever you switch it on, immediately it will start detecting issues. And that's probably also really important, it enables you as a site reliability engineer to capture even more and also apply them to whatever is pushed into production. It helps everyone to guide the troubleshooting. And last but not least, we visualize all the dependencies, not only the service map, but way beyond. We should visualize everything that's going on. And ultimately, that's happening in a single platform. So your business will benefit because you're focused on what matters the most. Your waste will be reduced. You can do more with fewer experts because your experts' practices and how they work can be pushed into policies, so they can focus on coaching rather than on setting up the tools all the time. And last but not least, or probably the most important one, it's all about reliability at your customers. And what I'm super proud at and really great to announce is that you can benefit from this as well, obviously. And I will show in a split second what we're launching in a few weeks. And I would really like to invite you to a couple new beta features that we're adding to our platform, really focused on Kubernetes troubleshooting. The platform obviously is there for a long time and many customers are benefiting, but we're launching a couple really specific Kubernetes ones that you can benefit from. So if you're using Kubernetes, feel free to reach out, use the URL or send an email to the person that invited you to this webinar, or reach out to me on LinkedIn. So you can take a look and really see how that data comes together. So what StackState likes to do is take a simplistic approach. And for many of the teams, that all starts with a service. And where we're looking at here are some of the new screens that we're adding to our product. So we're looking here at an overview of the various services that your team is using. And I've selected here the namespace, so we're narrowing down the data of where your team is responsible for. And then, and that's probably the most important one, we serve you with all the information that is needed to build that understanding. For a service, obviously, there are the metrics that matter. And in this case, the golden signals are automatically derived and are shown in the UI: throughput, error rate, and latency. And that is important because, as you can see, something is happening and you need to take action there. But the question is, what is causing it? What is also important is to understand the bigger picture. It's not only about the metrics of the service, it's also about the individual pods, because probably there's a little deeper behavior happening. So what StackState does, it collects metrics. And as I shared in the beginning, metrics are just one piece of the puzzle. The second one, which is really important, is to understand relations connecting the dots. And in this case, we want to know what are the pods running in this particular service. Because if something is wrong with a pod, that's definitely where you need to pay attention. So we can easily identify, based on the fact that the dots are connected under the hood, we can identify what's going on. And what matters to a pod, I mentioned that before, are the events. For example, when are they terminated? When is a new container pulled? When is it restarted? And all these type of capabilities. So all the events that are produced by Kubernetes are automatically collected and shown here. And you see what I just did? I clicked from a service straight into a pod without going back into my cluster to get the events. They are there. And these are the events that are related to this particular pod. And the same applies to metrics. And based on the research, we've identified that the metrics from a service are different than the metrics from a pod. Not only the ones that are produced, but more important, the ones that matter for you to make a decision. Events, metrics, and then really important, the logs as well. What are the logs and what are the elements or the issues that you see in here that you need to go over and build a deeper understanding? And these are just some of the elements that are important. And then last but not least, and you've seen that already, there are various monitors or policies, if you like, applied. Over here, we see a service level objective, which matters at the service level. But if you go deeper, you'll see that at the pod level that was in a not so nice state, you see, for example, too many restarts due to out of memory. So these are some of the practices that your site reliability engineer can define once and then apply to all the teams that are working and deploying applications to Kubernetes. Well, there's a lot more to tell, a lot more to show, but really what I would like to do is to invite you to connect to us, and then we go deeper into this, and you can experience it yourself. All right, and with having said that, I do feel that there's still quite some time for questions. I don't know if there are questions coming in, Genevieve.
Yes, we do have a few questions for you, Andreas. So for the first one, analyzing of logs seems to be a huge task and poses little challenge due to multiple containers and different logs for each mini deployment of Kubernetes. Is there a best way to assemble the logs in a single location to ease logs analysis and troubleshooting?
Yes, that's a really good question. And a part of the question is also the problem you're calling out. All these logs are generated by individual components. And if you're troubleshooting it, it's really hard to know where to go. You're traveling all the time. And then there are multiple ways to solve it. Obviously, one way to solve it is to put everything into a central solution. And there are many of these log aggregators that will do so, and they will certainly help you to put them into a single place. And then from there on, you start crunching them. And that's a way to solve it. The other way to solve it is not to travel or to go to your particular pod by using the command line or by going in there, but to simply have the logs, as I've just shown you, at the moment that you need them. So StackState takes a slightly different approach. The logs are in a central place, but not shown in a central way. The logs are only shown at the moment that you're looking at a particular component and you want to enrich your understanding and look at it. And I would say both approaches have benefits. If you're really focused on the expert, probably a central place might work. But if your goal is to troubleshoot quickly with people who don't know the entire structure, having the log simply at your fingertips is what we believe a better approach, because then, you see only the logs for the component at the time that you're looking at it.
All right, thank you, Andreas. All right, so the next question from the audience is setting up Kubernetes and troubleshooting issues during setup seems to be very complicated. Does the presenter, do you, help by pointing us on a full guide to install Kubernetes?
Yeah, that's actually, let me come back to the real question a little bit at the end.
Sure.
There's that dilemma. There's actually the two stages. There's the one stage, companies who are new to Kubernetes. How do I set up my platform? What are the best practices there? What are the tools I need to set up to enable the teams to start pushing applications to Kubernetes? And let's call that stage one. And there's a lot of stuff which is, I would say really the Kubernetes layer, and there are a lot of tools and entire ecosystem around it. The container management, the container platform management solutions that will focus on that. And I'm not the expert in that particular area. So I would like to, if you need more information, go to other sources. And that's where StackState is really focused on. Then there's the second stage. So imagine your platform is more or less running stable, your various clusters and your teams are enabled to start pushing applications out. What we see there is that the platform itself is often pretty stable. So not a lot of disruptions and not a lot of issues in the Kubernetes layer itself. That belongs in stage one and not necessarily in stage two. Where then the issues come around the corner is really in the interaction between the applications being pushed onto Kubernetes or the applications running on that particular cluster. And that's where StackState is in particular strong at, and also where our focus is. And that's why, for example, these policies and bringing all the data into a central place is so important to help you troubleshoot that. Troubleshooting, the first part, stage one, simply requires different tools and a different mindset. I hope it's probably not the answer you were expecting, but simply because my knowledge is in stage two and not necessarily in stage one.
That makes complete sense, Andreas. All right, so for the next question that we have, do you find that SRE and platform teams spend a lot of time on policy enforcement?
Do I find they should? Is that the question?
No, it says, do you find that they are spending a lot of time on policy enforcement?
No, I don't think so. And I actually think they probably should do a bit more, and not necessarily to be the horrible guy in the company restricting everyone, but more for the reasons that I've just called out. There's simply a lot of knowledge that a regular engineer, software developer doesn't know, which a SRE or platform engineer knows. So defining this in policies and rolling them out, and they're not necessarily the kind of limiting policies in the sense they're limiting the engineers in deploying and pushing software out, but they're really there to observe how applications are behaving and whatnot. So if you're lacking, so if your landscape is pretty unstable for all the teams, it might be a really good way to spend a bit more time there. And then obviously there's also the compliance and security, which can be a bit more limiting. But if you think about it from a reliability perspective, I do think it's a really good approach to focus quite a lot on it and push that out. Yeah.
All right, we got another question. What are some of the tips on helping people become Kubernetes experts? Or what are some of the ways that you would recommend, Andreas, that they should learn, or they could learn?
Yeah. There's a colleague here in the room who would say use ChatGPT to familiarize yourself, but that would probably be not the right answer here. No, I'm kidding. Well, first and foremost, obviously go to YouTube. There's a lot of stuff that is out there that you can use and familiarize yourself. There are a couple really good newsletters. There's the Learn K8S newsletter, which is serving tons of articles. If the person who's asking this question would ping me on LinkedIn, I'm happy to share an entire list with sources that can help, or I'll put it in the follow-up email. There are tons of newsletters that can help you there. Yeah, and simply make use of the official certifications. In April, there's KubeCon here in Amsterdam that you can participate, and there's also obviously the KubeCon in the US. And these are the shows that really will help you to understand what's actually going on and grow in your practice. Last but not least, yeah, just start knowledge sharing sessions in your company. It's super low level. There are always people who know something about a particular topic. So start at knowledge sharing. And if you're still remote, which in our case, a lot of engineers are also still remote, I still believe that is possible and fun to do.
Absolutely. All right, so we have one more question, which is, do you work on top of Prometheus and Grafana, or do you replace them?
That's a good question. So there's a slightly different metric store in StackState, which is working exactly like Prometheus, but storing the data longer. It's called Victoria Metrics. So in that case, we absolutely replace Prometheus. We've also seen that many teams get started relatively easily with Prometheus, but then the data duration of the storage, as well as the hassle to keep it up to date and to keep every Prometheus instance running can be quite difficult. With regards to Grafana, it can run on top of StackState because sometimes you would like to have additional business metrics that you collect and that are not visible in StackState itself, because we're really focused on troubleshooting Kubernetes and not necessarily on showing every metric. So then you can use Grafana. StackState has a slightly different view on dashboard, so we're not there to replace Grafana as such from a dashboarding perspective. But our goal really is to bring the metrics, as you've seen on a couple of the designs, bring the metrics into the view or into the component that the engineer is looking at, because seeing the particular metrics like latency and error rate from the servers you're looking at, we believe is really important to judge what's going on rather than going from one dashboard to the other. So we take a different approach. We bring the metrics into the view that you're looking at rather than having endless numbers of dashboards showing all kinds of information. So we could replace as well as, if you still like, you can put Grafana on top.
That's really good to know, Andreas. Now, I know we have like 5 minutes left, but so we have a couple more questions. So for the next question is StackState able to relate information between clusters, or is each area viewed separately?
No, it can absolutely relay data across clusters. Really important sometimes, because a security group that is changed on one cluster might still have an impact on particular services in the other. So across cluster information is important. StackState uses that information for what we call problem clustering or probable cause determination. So having the entire picture, connecting all the dots is important. For the people who really like to know, there's a graph database under the hood that really builds the entire tree structure. We call that topology, and that helps you to see what's going on, even across cluster or across technology even, if needed.
Now, I know we've got a couple of questions about the actual free trial and how long the free trial is for. On the website, it actually says it's like 14 days. So please ignore it. This is a different offering. I did not update the web page, so that is my fault. It actually is going to be for 2 months. So regardless of what the website actually says, it is 2 months. All
Thanks,
right.
Thanks.
And then the last question that we have is, can StackState work with OTel?
Yes, there is. So the entire standardization, for the people who are not familiar with OTel, it stands for Open Telemetry. And actually the entire observability market, I would say, is standardizing towards two practices. One is PromQL, Prometheus query language, in particular to create your dashboards and these type of things. And the other standardization is around Open Telemetry, standardizing on trace, on metrics, and really bring that together. An example, what we do with that is if we ingest trace information, we actually do two things. We derive topology from that. So we build a structure and an understanding to connect the dots, as well as we automatically extract the golden signals, error rate, throughput, and latency. So whenever an engineer starts using that, feeding the data into StackState will then be helpful in understanding what's going on. Obviously, Open Telemetry is much bigger, but these are some of the capabilities that StackState does with it.
All right, so that was our last question, Andreas. So I personally want to thank you, Andreas, for all your time today and presenting on this, very important topic of troubleshooting Kubernetes. And also, do you want to say a few words to the audience before we close out?
Yeah, I really hope to meet you next time at a physical face-to-face event to see you. If not, I'm absolutely happy to have a chat or whatever. If you want to know more, feel free to reach out. Thanks for joining us and staying with us the entire webinar. That's really appreciated, and looking forward to see you later.
Absolutely. Bye-bye, everyone.
See you.